Hello guys, today I'm going to apply seismic loads to the building. So let's define it first. We have to modify it. We don't need eccentricities. Let it be in x and y direction. Seismic, seismic zone factor, you can find it in IS code 1893 part 1 2002. In this map we are designing for Bangalore. So Bangalore lies in blue region, that is zone 2. So let's choose for zone 2. We have to check the zone factor. For zone 2, this 0.10. So let's make it 0.1. The site type, it depends on the type of soil condition. It may be rock or medium soil or soft soil. Let it be medium soil and it's type 2. And importance factor, let it be 1. And response reduction factor, it's given 5. But what we are going to choose is response reduction factor. For ordinary RC moment resisting frame, it is given as 3.0. So let's input this as 3. Everything fine. Okay. Now let's analyze it. Before analyzing, we don't need the wind load to run. So let's choose it. Make it do not run. Let's run it now. It's a deflected shape. It denotes that analysis is complete. Let's design for the concrete frames. I have already said that we have chosen auto select. So the beams in the columns of the minimum size were used, but now everything is passed. Okay, fine. We have done the seismic analysis. Now let's move on to response spectrum function. Let's define the function response spectrum according to IS code 1893. Let's name it response spectrum. Site condition we already know, 0.10. Let the damping ratio be 5%. Okay. RS is our response spectrum function. Now let's move on to load pattern. Load case. We don't need wind load anymore. Let's delete it. Add a new case. Response spectrum. Choose it here also. We are going to add two, u1, u2, that is x direction and y direction for response spectrum. We need scale factor. Scale factor can be found, it is given in Skyfi Labs itself. It is found by I into G divided by 2R. This importance factor into acceleration due to gravity divided by 2 into response factor. We define response factor as 3, 9801. So value is 1633.5. Same for here also. Let's make the directional combination type as CQC3. Okay. We have successfully assigned the response spectrum function. Let's analyze it. Before analyzing it, we don't want dead load and live load, so let's make it not to run. Run with the seismic and response spectrum function. The analysis is done. Let's design it. I think it's consuming too much of time. Sixteen members might have failed. Let's reiterate it. And the design part is over. All the members, let's verify it whether all members are passed. Yes, all the members are passed. Now the response spectrum analysis is over. we can check the story response plots also. The blue represents the x-axis and y represents the y-axis. Okay, now let's unlock the model. Now instead of response spectrum, let's try out time history. We are going to insert a new file in it. Name it time history. Example time history story data. It is given by Skyfi Labs. Let it be fixed format. We don't need to change anything in it. And before giving OK, we have to check the file to check the header lines. In this 2, 3, 4, 5, 6, 7, 8, 9. 9 lines are header lines, and then only data is present. So let's make it 9. Number of points per line is 1. Okay. Example time history data is defined. On load cases, we don't need response spectrum. Let's delete the case. Let's add a new case for time history. Load case type is time history. So and let the acceleration in only one directional, make it unidirectional. Example time history data, and we already know the scale factor is 633.5 from this calculation. Let others be done. Okay. And one more thing, load patterns, seismic load. Since it is unidirectional, you have to uncheck the y direction box. Okay. Now the model is ready for analysis. We don't need dead and live load, only seismic and time history we know. Run it. This time history data is for Bhuj earthquake that was happened in Gujarat. Let's design it. Analysis part is over. Once more, let's reiterate it. First of all, we just took the seismic load, that is the static design, and then when we went for functions, that was dynamic analysis. The use of response spectrum is for linear dynamic analysis, and the use of time history function is for nonlinear dynamic analysis. So by now we have applied dead load, live load, wind load, seismic load as a dynamic, both as linear and non-linear also. Design is fine. Let's check all the members are passed, and we can get the report from here. It's the full report of all our loads. We can export it to Word document, or we can even print it. That's the end. So thank you.